distribution. Sometimes we think double distribution. Oftentimes students call this FOIL method, FOIL technique, or teachers in the past. I just wanted you to be able to understand that we're just multiplying. So when I multiply, distribute this through, 2x times x is going to be 2x squared. If I went outside 2x times negative 2, it would be negative 4x. Inside negative 5 times x is negative 5x. And then the last term's negative times negative would be positive. 5 times 2, 10. I could combine my like terms in the middle. We end up with 2x squared minus 9x plus 10. I know that we've done that before. We feel pretty good about it. All right, last would be the quotient. What I'm doing now, the shorter hand, again, order matters, but I'm going to be going f divide by g of x. Again, what we may have seen in the past, or really what we're actually going to be doing, is I'm going to be putting f of x over g of x in this nature. So I don't have to scroll. Could somebody remind me, please, what was f of x? 2x minus 5, and then g of x was x minus 2, correct? All right, now is there anything that reduces here, or cancels, or cleans up, or anything like that? Nothing factors out. So we're done. All right, so guys, like I said, combining functions, you've been doing this for years. If there's anything, quote unquote, new, it's this notation or this notation. If there's anything new, that's it. It's not the math. It's not what we're doing or how we're obtaining. I just want to be very adamant about that. You know what you're doing here. We just need to also know how to read it, how to say it, how to write it. Okay? All right, so guys, composition of functions. I know that we've talked about it very, loosely or in general, and I'm sorry, I'm going to read this off to you. Again, I typed it up this way because I wanted you to hear it this way. That sometimes in math, we input a value x into a function. We do that all the time. We've been doing that the entire chapter. But then we could also use the output or the answer to plug that now into another function. So again, trying to reiterate here. I could evaluate this function over here, so we'll say function number 1, and then its output is immediately put into a new function over there. That happens all the time. So based on the result of this, that's going to dictate that because that gets plugged in. That's what we're talking about with these composition of functions. Okay? The output of the first function becomes the input for the second function. When we use the output or the y of one function as the input of another function, this is what we call a composition of function. So to sum all of that up, here's what we want to think about. Again, how do I rationalize this in my mind? What we want to think is putting a function into a function. Okay? Like I said, there's various ways that you could handle it, various ways that you can do it, but quite literally, you're taking one function and you're putting it into another function. Okay? So that's what we have going here with our definition of composition functions. Again, I wrote it one way previously. The newer way of writing this is, I'm going to go a little bit larger here, is that we are evaluating what we say f of g of x. That's the of. Again, this is how we know that I'm putting the second function into the first function. We could absolutely have g of f of x. Again, the order matters tremendously. But f of g of x, what that really means is that we have function f, and we're putting function g into function f. Okay? That's what that means. All right? I'm hopeful, but maybe I'll back up. Have we done this before? Have you done this before in previous classes, put a function into another function? Like, do we recognize this f g of x? But this is new, the f of g of x. This is new. Am I correct with that? Okay. So again, we want to lean into the fact that you've done the work before. You've done the math, so to speak. What is new, again, is the notation. All right? So we say that the domain of f of g of some value, so the domain of f of g, it's going to be the set of all x in the domain of g such that g of x is in the domain of f. All right, so what that means is we have to start with the initial input. So g of x is what I'm putting into function f. I have to start with that domain. And I'm going to consider what's the domain just of g of x. Then at the very end, once I've done the work, f of g of x, then I'm going to look at that domain. And I'm going to overlap the two. That's how we would handle this. So I've got a couple more slides that are getting into that. Now, sometimes you have a numeric value like we do here, and we could go ahead and tackle that. So if we wanted to find f of g of 3, again, you got a couple ways that you could do this. Again, it really kind of boils down to a personal preference thing. Could we go off to the side and figure out g of 3? Knowing that g of x is 2x plus 1, could I plug a 3 in place for x, clean this up, and determine that g of 3 must be 2 times 3, 6 plus 1 is 7? So if I know that g of 3 is 7, and my task, again, remember, was to find f of g of 3, could we now put right here, could we put something in place for g of 3? Well, we just established that that's 7. So are we really just finding f of 7 at the end of the day? Now, I know that f of x is 3x minus 5. All we're doing is now we're putting a 7 in place for x. And we could clean this up and evaluate it. So, oops, I would actually do the work here. 3 times 7, 21 minus 5, we could establish that f of g of 3 is 16. Like that. Does everybody see how we got there? All right, now, I've said it a couple of different times and ways here, but that's one option. Okay, another option is you could just do this all in one shot. Okay, we know that we're going to put function g into function f. So I know that function f is going to be 3x minus 5. But in place here, I'm going to be putting g of 3. Well, what's g of 3 going to look like? It's going to look like g of 3, remember, being 2x, but we've put a 3 in its place, plus 1, like that. I feel like this is kind of getting a little confusing, but this is really what's happening. So we've got 3, 2 times 3 plus 1, 2 times 3, 6 plus 1, 7. And it's starting to look familiar, I hope. But as you can see, we get the exact same answer. To me, it kind of boils down to which type of person are you? Are you the type of person that if you've got like 17 different calculations, do you want to put it all into your calculator all at one shot and then you hit equals at the very end? Or are you more the type of person that you go calculate this, go calculate that, and then you put it all together at the end? That's probably, if I'm being honest, that's a little bit more of how I am. Instead of, I'm probably not a, let's do, 473 keystrokes and then hit enter one time on the calculator. I'm probably less that guy. So again, is there a right way or a wrong way? No, definitely not. How do we feel about this though? I need a little bit of space. I'm going to erase this one, not because it's any less correct, but just need the space. If we wanted to find g of f of 3, again, now I could go off to the side and figure out f of 3. So again, using function f of 3 is going to be 3 times 3 minus 5. So it looks like f of 3 is going to be 9 minus 5, which is 4. So again, that's not my answer, but that's very much what I'm going to be putting into function g. So g of f of 3 we just established is 4. So 2x plus 1, but we're now putting a 4 in place. So what is g of f of 3 going to be equal to? 2 times 4, 8 plus 1 is? That's where everybody says 9, but nobody said it out loud. So, all right. All right, now, where it might also get a little weird, could we put a function into itself? Could we find f of f? I suppose, like I said, a bit abnormal, a bit strange, but you can do it. So f of 2, what this is really saying is we want to find f of 2. So we're going to put the second function, f of 2, into the original function, f of x. So my style is I want to go off to the side and figure out what is f of 2. So function f, in red there, we've got 3x minus 5. I'm going to put a 2 in place. It starts to look very quickly like f of 2 is 3 times 2, 6 minus 5 is 1. So when I'm finding f of 2, that means that I'm going to be finding f of 1. So f of 1, 3 times 1 minus 5, 3 times 1, 3 minus 5 is negative 2. All right, is everybody understanding where we're going with this or where this came from? Now, like I said, this is what it's going to look like if we have a numeric value that we know we're plugging in place for x. But lots of times it's more generic than that. Lots of times it's going to be more along these lines to where, yeah, we've got f of x is equal to 2x plus 5, g of x is 4x squared plus 1. Yeah, we've got all that taken care of. So this first one, I've got what I like to call an anchor example. I want you to be able to see it. You've got all the steps. So if we wanted to find f of g of x, that means that I'm literally putting g of x into function f. I'm not just evaluating at one place, though. I'm not just saying, oh yeah, let's find when x equals 3 or when x equals -1. No, we want generically all of it. We want the whole thing. So as we can see, g of x is the blue, 4x squared plus 1. I'm going to put that into function f being 2x plus 5. So 2, plugging function g, and so 2, 4x squared plus 1 plus 5. And now from here, it's literally just do the math, clean it up, simplify. So when I distribute 8x squared plus 2 plus 5, combine like terms, our final, as far as we can go, is 8x squared plus 7. Okay? If we did g of f of x, we could do literally the exact same thing, but only in reverse. So now we could find g of f of x, as you can see, is 2x plus 5. We know that function g is 4x squared plus 1. And in place for x, we decide to put 2x plus 5. So the challenge that we have ahead of us here is with, multiplying the 2x plus 5 times 2x plus 5. We're going to have to clean that up. Again, probably a distribution, or like I said, some of us call it still FOIL technique. So multiplying the first 4x squared outside is 10x, inside 10x together, that's 20x. Our last term, 5 times 5, 25, plus the 1. So here, when I distribute the 4, we're quickly going to call that 16x squared plus 80x plus 100 plus 1. Combine our like terms there at the end. We finalize that 16x squared plus 80x plus 101. Guys, do we have any questions about g of f of x? Now, I'm kicking myself for not mentioning it on the previous slide, but are we noticing that f of g and g of f are not the same? Again, is it possible that maybe somehow, some way, g of f equals f of g? Yeah, it's possible. It's out there. That'd be pretty rare, but we could do that. Okay? Now, what if at this point, in part C, we are supposed to now evaluate f of g of -1/2? Could we do this exactly like we did on the previous slide? Go off to the side, figure out g of -1/2. Once we get that solution, then we plug it back into function. We can do it like that. But is there a shortcut that we've created? Understand that by doing this work, we evaluated that f of g of x is 8x squared plus 7. Now, as soon as we learn what we want to put in place for x, all we have to do is plug it in place. So here, all that this is saying, off to the side here, is that we're going to let x equal -1/2. So I'm going to take my solution from over here, which was f of g of x, and we're instead going to evaluate f of g of -1/2. So what that's going to look like is our solution 8x squared plus 7, and we're making the decision to put -1/2 in place for x. So as we clean this up, we have 8, -1/2 squared is 1/4, plus 7, 1/4 of 8 is 2, plus 7, we obtain 9 as our solution there, guys. How do we feel about that one? Now this, we understand, this way, this method only works if we've already done the work to get f of g of x, but hey, that's a shortcut. Could we have done it the other way? Sure, we've practiced a few of those before. All right, so a little bit more on the domain. I know that I've talked about this. This is actually the third time we're going to talk about the domain, but it is important that we understand how we find the domain of a composed function. So to find the domain of some compound function, f of g of x, however, whatever notation it's in, we've got to determine or pay attention to two of the restrictions. First, since we're using g of x as the input, we've got to start by evaluating, okay, what is the domain of function g? That's the first thing we've got to have in the forefront of our mind. Okay. Then from there, the second thing, and this could get a little wordy, so instead, I'll just try to sum it up. We're figuring out f of g of x. Right? Like you're going to end up with a new function, f of g of x. We'll look at that function and determine its domain. Now we're looking at where that domain and the g of x domain, where do they overlap? Okay? A little bit of practice with that. Let's try it. Let's find f of g of x. Okay, we got this. F of g of x. There's f, there's g. I like to use different colors. I think we see it a little bit better. So if we wanted to hit this all in one shot, I know that function f is x squared minus 9. I'm literally putting function g in to function f, so in place for x, I'm putting the 9 minus x squared under the radical, so the square root of 9 minus x squared. We've got it set up. Now we simplify. We know that when you square a radical, that those are going to cancel, and we would end up with 9 minus x squared minus 9. Here, the 9 and the negative 9 are going to subtract out. So my final solution there is negative x squared. So f of g of x is equal to negative x squared. First part, are we good with that first part? Putting one function into the other function. Are we feeling like we're seeing it a little bit? Okay, outstanding. Now, from here, we want to find the domain. So here's the spot where people make mistakes. We have two things that we have to check. A lot of times people only check one. If we're just looking at f of g of x, guys, you practiced it yesterday. You know what that sketch is going to look like. Oh, yeah, parent function reflected. There it is. Looks like our domain of this would be everything, negative to positive infinity, correct? That's part of what we have to look at. The other part that we have to look at is the fact that, well, this was the g of x. That was my input originally. That's what we were putting in place. So I can only put in place the domain of function g. Does that make sense? So I also have to consider the domain of function g, which I know that I am not allowed to have a negative under the radical. Can I have 0 under the radical? Yeah, I can have 0 under the radical. So what value of x is going to allow me to equal 0? So right here, what value could I put in place for x that's going to make this whole thing under the radical go to 0? 3, or negative 3, correct? 3 squared is going to be 9. Negative 3 squared is also going to be 9. So 9 minus 9 is going to be 0. Now, we have a problem if we have a negative value under the radical. So do you agree that if I have anything bigger than 3, this whole thing is going to be a negative under the radical? That's not defined. So we know that we have to be less than 3. We also have to be, we have to be less than 3. What happens if I'm smaller than negative 3? Like, what happens if I use like a negative 5? Negative 5 squared is still 25. That's going to cause a problem, isn't it? So that means that I have to be greater than 3, but greater than negative 3, but less than positive 3. So, and everything in between would work as well. So my domain of the f of g of x part, that part, it was everything. Up here, it was from negative 3 to 3. They're going to overlap at negative 3 included to 3. Okay, we seeing that a little bit? All right. So hopefully we have time to tackle this next one. There's just a couple of different ways that you could utilize. So this next guy, it says that the figure shows the graph of function f on the domain from 0 to 9. The function g is given by, we see it right there, g of x is equal to 1.2x cubed minus 4.7x plus 6.2. Again, the graph up top, that is function f. So the question, they have to make it weird. They say the function h is defined by h of x is equal to g of f. So what they're saying is, we did g of f, but we're going to call that function h. If you feel like, that feels like we're overhandling it, I agree, but that's the way that they're choosing to do it. So g of f, meaning I'm literally going to have to put function f into function g. So what we are supposed to do is find the value of h of 6. So h of 6. Well, if h of x was g of f of x, doesn't that mean that we're supposed to now find g of f of 6, which is g of f of 6? All right, so this is not as complex as it may seem. If you're looking around for function f, we don't have the function, but we have the graph. What that's saying, f of 6, is that when x equals 6, what's the function value? I'm looking at the coordinate right there. So that tells me that f of 6 is just equal to 1. So now I can do a little bit better than this, and I could say that, well, we're trying to find g of, well, f of 6 is just 1. So at the end of the day, could we now go right back up here and figure out 1.2 x is just 1 cubed minus 4.7 x is just 1 plus the 9.62. So we have a lot of weird look in decimals, but we end up with 1.2 minus 4.7 plus 9.62. Does anybody have that? I think I had it written down somewhere. I haven't looked at my notes in a while. But 6.12 is what I'm getting there. So guys, the reason why I want to pull this problem in is I want you to see that we could evaluate functions graphically. We could evaluate the traditional way. We can put a function into a function. But again, just reading through, is this problem making sense? Okay, this is one of those AP exam spotlight questions. Like this is one like that you're going to very potentially see something that looks like that. It's not nearly as difficult as it may seem initially. All right, same story with one that looks like this. I believe this is our last one. Hopefully we have time to. Oh yeah, we have time. I don't know. I was looking at the wrong part of the clock, I guess. All right, so if we take a look at this next example, this is another exam spotlight question. As you can see, we're given two different tables. Nah, I don't want to say it that way. We're given one table, but we're given two different functions within the table. Okay, we have f of x. Well, the way that we want to read this is, all right, well, what's the f of x value when x equals 2? Negative 2. Oh, I guess it's 0. But the g of x value when x is negative 2 is equal to 1. Are we seeing the difference there? We're running two different functions. All right, essentially. So our question here, the table gives values for the functions f and g at selected values of x. Functions f and g are defined for all real numbers. We're supposed to let h be the function defined by, again, we'll try to highlight this. H of x is going to be f of g of x. So what's the value of h of 1? So again, just like we did previously, if we're trying to find h of 1, but we knew that h of x was f of g of x, doesn't that mean that we're just finding f of g of 1? So my first task is saying, hey, let's go figure out off to the side, what is g of 1? So when x is equal to 1, what does g equal? Looks like g of 1 is going to be 0. Good, so g of 1 equals 0. We've got that, and no, unfortunately, that's not my answer. But now I have a much better chance at figuring out f of g of 1. So f, of course, if I write this out, f of g of 1 now being 0. F being the top row, I'm going to erase what we don't need. We don't need this stuff anymore. Also, probably don't need this because we're focusing on function f, and we're finding f of 0. So f of 0 looks like that's going to be at negative 1. B is the winner. All right, guys, do we see how we got there? So you could evaluate based on a graph. You could evaluate based on a table. You could evaluate based on, hey, here's a function for, or a value for x, plug into the function. So there's a lot that we can do, but at the end of the day, can we put one thing into another thing, right? That's really the long and the short of it. All right. So guys, I've got a worksheet here for section 1.8 coming your way. We're going to skip out on the bookwork today. Just focus on the worksheet.